Hello, my dear student. I'm Mr. Mahmoud Abdullah, and today we have a new session in LO number 1, quadratic function. In our LO today, we will finish the quadratic function concept. This is the last session in LO number 1. And in the next session, we will begin in LO number 2 in math. Now let's finish our LO. The concepts that we will take today: Argand diagram and related roots. Let's start with Argand diagram. In the previous session, we talking about the complex number and the types of root of the quadratic equation. The quadratic equation has 3 types of root: 2 real different root, 2 similar real root, and 2 complex root. And we have also noticed that if the coefficient of the quadratic equation are real number, then the imagined roots or the complex root will be conjugate. Okay, now Argand diagram. Argand diagram is a method to represent the complex number, to make it as a Cartesian coordinate. Argand make a Cartesian system consists of 2 axes, horizontal axis and vertical axis. Let's start with the shapes of complex number. How can we write complex number? I will write a complex number: 3 plus 2i. This is a complex number. We have explained that the complex number has 2 parts, consists of 2 parts: the real part, which equals 3 here, and the imagined part, which equal 2i. This is a complex number, and this form, this shape, called algebraic form. This is algebraic form. Then the algebraic form of the complex number wrote as a plus bi, which a here represents the real part and b represents the imagined part. We will notice here that a equals 3 and b equal 2. This form is the algebraic form. If we have 2 complex number, 2 equivalent to complex number, and we know the value of the complex number. I said, by the way, 2 minus 4i, this is a complex number, equal another value, and this value is have unknown letters like x plus y plus 2x minus y, 2x minus y, I. This is an equation. This number is a complex number, and it is equal the other value. How can we get x and y? In this equation? Because these 2 sides are equal, then the real part in this side must be equal the real part in the other side, and the imagined part in this side must be equal the imagined part in the other side, so that we will make a 2 equations and solve them to get x and y. We will solve the equation by elimination method or substitution method. The first equation, the real part here, the real part in this side, is the part which didn't multiplicated by I. This is the real part. Then the real part here is x plus y. We will equal it with the real part here, which equal 2. We make an equation. Equation from the first degree in 2 variables. The other equation, we will make it from the imagined part. The imagined part here is the part which multiplicated by I. This is the imagined part. Then 2x minus y is the imagined part because all this value is multiplicated by I. Then 2x minus y, the imagined part, will be equal the imagined part in the other side, which equal minus 4. And this also is an equation from the first degree, has 2 variables. To solve these equations, these 2 equations, we can use elimination method. Elimination method, we can get this equation and put it under this equation, and we add the 2 equations. Y will be eliminated with minus y. Then we can use elimination method. We can also use substitution method. Substitution method depends on make this equation, make the variable alone in its side, and substitute with its value in the other equation. We can use any of them, okay? But if one of this equation from the second degree, we only can use substitution method, not elimination method. Let's apply elimination method in this example because it is a simple equation. 2x minus y equal minus 4. equal minus 4. اتفضلي يا رودان. طب لحظة واحدة. Okay, let's continue solving this equation. We will use elimination method. We will add the 2 equations. Positive I will be eliminated with negative I. X plus 2x, it will be equal 3x. 2 minus 4, it will be equal minus 2. Then x, it will be equal minus 2 over 3. Minus 2 over 3. Now, we get the value of x. We will substitute with it in the other equation or any equation to get the value of y. Then 2 times minus 2 over 3 minus y equal minus 4. Then minus 4 over 3 minus y equal minus 4. Then y will be equal minus 4 over 3 plus 4. Then y will be equal minus, we will make the denominator equal 3. This number 4 will be 12 over 3. 12 minus 4 equal, 12 minus 4 equal 8. Then the value of y equal 8 over 3. Then we get the value of y and x from this equation. Then if 2 complex numbers are equal, then the real part must be equal the real part, and the imagined part must be equal the imagined part. Now, let's take diagram of Argand. Diagram of Argand is a way to represent the complex number. As I said, diagram of Argand consists of 2 axes. 2 axes. The horizontal axis will be represent the real part of the complex number. Then this axis is not the x-axis as we know. It is the real. the real part axis, then we will represent this number as an ordered pair. We can also write the complex number as an ordered pair. The ordered pair has two coordinates. The two coordinates are the two parts of the complex number. The real part is the first coordinate in the ordered pair, and the imagined part is the second coordinate of the ordered pair. Then we can write the complex number until now with two ways. We will take the three way when we explain Argand diagram. The first way we represent the complex number is algebraic way. The algebraic way wrote as a plus bi. The second way to represent a complex number is an ordered pair. The first coordinate is the real part. The second coordinate is the imagined part. Then this number as an ordered pair is 3 and 2. This number represents the real part, and this represents the imagined part. As this ordered pair, we can represent it as this diagram, Argand diagram. Then Argand diagram is a way to represent a complex number by a point. This axis are the real part axis, and this axis, this vertical axis, is the axis of imagined part. When we make numbers to this axis at any Cartesian coordinate, 1, 2, 3, 4, 5, and also on, -1, -2, -3, -4, this axis 1, 2, 3, 4, 5, and this axis -1, -2, -3, and also. Now, how can we represent this complex number? For example, its real part equals 3, and its imagined part equal 2, then this is the point which represent this complex number at Argand diagram. If we called this complex number with that letter, the complex number, we will call it Z. Then this point represents Z. Okay, Z, which equal 3 plus 2i. This is the algebraic form. This is an ordered pair form. There is another form for the complex number, and this form called triangular form. This form, the triangular form, wrote as z equal L open bracket sine theta plus I times cosine theta. Sine theta plus I cosine theta. I'm sorry. Cosine theta. Cosine theta plus I sine theta. I'm so sorry, I make a mistake. Then this is a triangular form for the complex number. Now, to get this triangular form, you want to know two variables. L which is called modulus of the complex number. L here called modulus. And theta here is an angle. Theta here is an angle, and it's called argument. It's called argument, okay? Then, if we want to convert from the algebraic form or ordered pair form to the triangular form, we want to know two important values. These values is L, the modulus, and theta, which is an angle and called argument. Okay? How can I get L and theta? By the way, L represented what in Argand diagram? If I make a segment from the origin point to the point which represent the complex number, this distance, this length unit is L. Then L here in the triangular form is the length of the length of the complex number, or the distance between the origin point and the complex point number. Theta, this angle, the argument, represented what? Theta is the angle which this segment make with the positive direction of the horizontal axis, the real part axis. Okay? Then L here represented the length of this argument, the length of the complex number, and the theta represented the angle between this vector and the positive direction of x-axis or the horizontal axis. How can I get L? How can I get theta? How can I get L? From Pythagorean theorem. From Pythagorean theorem. Because this side of the triangle, this is right angled triangle, by the way. This axis or this side represented y, which equal 2, and this axis, this side, represented x, which equal 3. Then we can get L from the ordered paired form or the algebraic form. L equal the square root of a square plus b square. Then we can get L from the algebraic form. Now, how can I get theta? How can I get theta? The argument. We can get theta by trigonometric functions using tan. Tan theta here, tan theta equal the opposite side over the hypotenuse. Then tan theta will be equal y over x. Y over x. Okay? Because y here represents the opposite side and the x represents the adjacent side. Also, you can get theta by using the sine. Sine theta will be equal y over L, because sine any angle equals the opposite side over the hypotenuse. And the L here is the hypotenuse. The modulus here is the hypotenuse. Or you can use cosine also. Cosine theta equal what? Cosine theta equal the adjacent side over the hypotenuse. Then the adjacent side, which equal x over the hypotenuse L, or sine theta, as we said. sine theta equal y over L. Then you can use any of these values to get theta. By the way, theta here, you can get it by the calculator. Shift tan to this value, or shift cosine to this value, or shift sine to this value. You now can get theta in a 60 degree, okay? With a degree measurement, I'm sorry. Now, how to convert from a triangular shape to the algebraic shape or the algebraic form. This will be an easy way. You will get L and multiply it by distribution. Multiply L times cosine theta. L cosine theta will be equal A, the real part. L times sine theta will represent the imagined part, which will be multiplied by I. Then if I have a complex number equal 3 cosine 60 plus sine plus I sine 60. This form is a triangular form. How can we convert it to the algebraic form or an ordered pair? By easy way, you will distribute the modulus to these two terms. Cosine 60 equal half. 3 times half equals 3 over 2. This is the real part. Plus sine 60 equal root 3 over 2. Then we will multiply it by 3. We will get 3 root 3 over 2i. And this shape is the algebraic form. And also we can write it as an ordered pair, 3 over 2 and 3 root 3 over 2. We can also represent it in Argand diagram. The x coordinate is 3 over 2 and the y coordinate equal 3 root 3 over 2. That will be a point in Argand diagram. How we make a converting from the algebraic form to the triangular form? If we have another complex number, and this complex number is as an ordered pair minus root 3 and 1. Minus root 3 and 1. This is an ordered pair. Let's write it as algebraic form. Algebraic form will be root minus 3 as a real part plus 1i as an imagined part. This is A and this is B. B here equal 1. Ordered pair, algebraic form, we can convert it to the triangular form. To get the triangular form, you want to get these two values, L and theta. The modulus L and the argument theta. Okay? How can we get them? First of all, we can get L, the modulus, by this law, square root 2a square plus b square, as we said from Pythagorean theorem. Then the square root of minus root 3 square, it will be 3. 1 square, it will be 1. Then the root of 4 will be equal 2. The modulus must be a positive number, by the way. Then the modulus here is 2. Now can we get the argument? The argument, or theta, we can get it by 3 ways, using tan or cosine or sine, because we get L. I will use tan. Tan theta equal y over x, or b over a, because x here is a and y here is b. Then b over a, the opposite side over the adjacent side. b here equal 1 and a equal minus root 3. Now there is an important notice. And we have explained this notice as in the first LO in semester 1, the trigonometric functions. This notice said that you now want to get theta. You will use your calculator and write shift tan 1 over root 3. Don't write the minus sign. Write the number with a positive sign. This is the first step. Then I will write shift tan 1 over root 3 equal. It will be equal the theta, the argument will be equal 30, because tan 30 equal 1 over root 3. 30 here is the acute angle. This is not the right answer, because we are not in the first quadrant. Then theta must not be acute angle. How can we get right theta? How can we get the right answer? The calculator gives us the acute angle, which equal 30, when we press shift tan 1 over root 3. This number 30 will be the right answer if we were in the first quadrant. But if we are in the second quadrant, the right argument is 180 minus the angle which the calculator gives us. Then if we get 30, we get 30 from the calculator. If we are in the first quadrant, theta is 30. If we are in the second quadrant, theta is 180 minus 30. If we are in the third quadrant, theta is 180 plus 30. If we are in the fourth quadrant, theta is 360 minus 30. Then by the calculator, we get 30. We get the acute angle. But after that, you determine the quadrant which your complex number lies on. And depends on that, theta will be right answer. The calculator give us 30 when we press shift tan 1 over root 3. Now we can determine the quadrant to get the right answer. How can we get the quadrant? From this sign. This ordered pair as the algebraic form, or this form, negative x-axis, positive y-axis. Which quadrant? Negative and positive. The second quadrant. Then this information, these signs inform us that we are in the second quadrant. Then use this converting, because we in the second quadrant. Theta is 180 minus 30, then theta is equal 150. Now we can get the triangular form because we get the modulus and the argument. the modulus is 2. Here we will write cosine 150 plus I sine theta, which equal 150. Now we convert from algebraic form to the triangular form. Okay? Now let's begin in the final concept in this LO, which is called related roots. An important concept, very important concept. Before I begin in related roots, اتفضلي اتفضلي. انتوا عايزين تستخدموا الكلاس ولا ايه؟ ماشي. Okay, I'm sorry. Let's continue. Now I was saying that before we take related roots between two equations, we must explain an important, very important relation between the quadratic equation coefficient and its roots. The quadratic equation, I will write a quadratic equation in its standard form: ax squared plus bx plus c equals 0. This is a quadratic equation. Its coefficients are a, b, and c. And these coefficients which help us to apply the general formula. The general formula, you remember the general formula. The general formula, which equal minus b, positive or negative, b square, the square root of b square minus 4ac over 2a. By the way, this value under the square root called, which we have explained it in the previous session, discriminant, which inform us the type of roots: two different real, two similar real, no real roots, complex. Now, there is a relationship between this coefficient, these three coefficients, and the roots of the equation. If they were real root or imagined root, this relation exists. I will suppose that this equation has two roots, L and M. I will give them symbols, letters. Then L plus M, that means the sum of two roots. You can get the sum of two roots without getting the roots itself. You don't know L equal what and M equal what, but you can get the sum of them using the coefficients of the equation without solving it. L and M equal minus B over A. Minus B over A. This relation, how can we derive it? This relation can be concluded from the two roots. These are the two roots. The first root is minus b plus root b squared minus 4ac over 2a. This is the first root. the second root minus b minus the square root of blah blah blah. If you get these two roots and add them, you will get this value minus b over a. Now, the second law, the second relation, the multiplicative of two roots. The multiplicative of two roots, m times l. We want to get m times l without getting the root itself. It also has a law. M times l equal c over a. C over a. How can we get it? This is the multiplication. How can we get this relation? By the two roots. If you multiplicated the two roots as a conjugate, you will get c over a. Then these two relations are very important relations because they connect the sum of roots and the multiplicated fruits with the equation coefficient. Then we can get the sum and the multiplicative without solving the equation, without solving, only with the coefficient. For example, if I have a question, an equation, 2x squared minus 4x plus 9 equals 0. This is an equation. Without solving it, without getting the two roots, tell me the sum of two roots will be equal what? As a number. And the multiplicative of roots will be equal what? Without solving it, without using the general law, from only the coefficient. We will lose the law. The sum of two roots, I will suppose the roots are L and M, then L plus M will be equal minus B over A. Then minus 4 equal 4 over 2. The sum of them will be 2, without knowing them. But the sum will be 2. The multiplication, L times M, will be C over A. C over A, it will be equal 9 over 2. This is the sum and this is the multiplication. Now, we will take an important information. If I give you the sum and the multiplication of roots, how can you make the equation? We want to remake the equation. We want to construct the equation. There is no equation now. But I give you two important information. I told you that this equation have two roots. It is a quadratic function. The two roots, the sum of them equal 2. And the multiplicative of them equal 9 over 2. Tell me the equation. We can make the equation by this law, an important law. X squared minus the sum of two roots, which equal L plus M, which equal 2 times x, plus the multiplicative of two roots equal 0. This will be the coefficient of x, and this will be the constant. And the coefficient here is 1. Let's construct the equation. We will set x squared minus, there is a minus in the law, get the sum of the two roots, which equal 2 times x, plus the multiplication of two roots, which equal 9 over 2, and finally equal 0. This is the equation. One of you can say, this is not the same equation which was written here. Because we can multiply the whole equation by 2 to get rid of this denominator. The denominator here is 2. But if you want the coefficient to be an integer number, you can multiply the whole equation by 2. If you do it, you will get 2x squared minus 4x plus 9. If you multiplicate it 2, it will be eliminated with this 2 equals 0. This is the equation which was written here. Then we can make the equation. We can conclude the equation. We can construct the equation by knowing two important information. Just two values. The sum of two roots and the multiplication of two roots. Let's take another example. But this example will be roots, and these roots are complex number, not real. If you know that there is an equation, and this equation have two root, two complex root. One of them equal 2 plus 3i, one of them. And I give you an important information. I told you that the coefficient of this quadratic equation are real number. Now, tell me the equation. Make the equation, construct the equation. Because the coefficients are real number, the two roots are conjugate. The two roots are conjugate. Then we can conclude the other root. The other root is the conjugate of the first root. Then the other root will be 2 minus 3i. Now, to make the equation, we will get the sum of two roots and the multiplication of two roots. Firstly, the sum of two roots. If you want the sum, add these two numbers. When we add complex number, we add the real part to the real part and the imagined part to the imagined part. We will say 2 plus 2 equal 4 minus, positive 3i minus 3i, it will be equal 0. There is no imagined part. Now, get the multiplication. The multiplication of two roots, we will multiply these two roots, and these two roots are congruent. We said that this is a special case in multiplicative. We times the real part times the real part and the imagined part times imagined part. 2 times 2 equal 4. Positive 3i times minus 3i equal minus 9i squared, and the I squared equal minus 1. We have explained this in the previous session. I squared equal minus 1. Then this value will be positive 9. Then 4 plus 9 equal 13. Then the sum is 4 and the multiplicative equal 13. Now we can get the equation. The equation is x squared minus the sum. The sum here is 4. Then x squared minus 4x plus the multiplication of the two roots, which equal 13. And finally it will be equal 0. Now we make the equation, the final equation, which roots are congruent, complex number 3 plus 2i, 2 plus 3i and 2 minus 3i. Now we can derive some relation, and this relation will help us to make new equations from a previous equation. there will be a given equation and a required equation. Your given equation, I will give you an equation, 3x squared plus 2x minus 1. From this given equation, you will get the sum and the multiplicative of its root. And I will ask you to make another equation. This equation, which I want, which you must construct, has a root. Its root has a relation with the previous root. He can tell you that the root is more than the previous root by 3. Then, if the first equation roots are m and l, the second equation roots will be m plus 3 and l plus 3. If the equation, the new equation, its roots is less than the previous roots by 2, then we will suppose that the first root are l and m, the second roots will be l minus 2 and m minus 2. If he said that the roots of new equation are the square of the previous roots, then the given roots are l and m, the required roots are l square and m square. If he said that the roots, the new roots, are 5 times the previous roots, then the first root l and m, the second root 5l and 5m. If he said that the roots of the new equation are cube of the previous root, cube power 3, that means if the first equation roots are l and m, the new equation roots will be l square and m square. But how can we get the multiplication and the addition for the new roots? Because we need the multiplication and the addition or the sum to construct the new equation. Let's make some relation, important relation. I will give you an equation. X squared minus 7x plus 9 equal 0. This is an important example. This equation, example number, this is example number 1, this is example number 2, this is example number 3. I will give you this equation, x squared minus 7x plus 9, which have a coefficient a equal 1, which have a coefficient b equal minus 7, which has a coefficient c equal 9. Okay, this is the coefficient. The 3 coefficients with us, we know them. Now, can you tell me, if we suppose that the roots of this equation, I want to need the roots. I need another value. We will suppose, we will give the roots the symbol L and M. Our roots are L and M. Now you can get L plus M from this law. And you also can get LM, L times M, from the law of multiplication, because this coefficient, all of this coefficient are known values. Now you can get L plus M. L plus M is the sum of the two roots, which equal minus b over a. Minus 7 equals 7 over what? Over 1 equals 7. Then the sum of two roots is 7. The multiplication of two roots, Lm, equals c over a. And c here, c in this example, equal 9 over a over 1 equal 9. Then we get the multiplication. And we get the sum. What you need after this, I need some values. I need one over m plus 1 over l. How can you get this value? From these values, you have L plus M and LM. You want 1 over M and 1 over L. How can you get it? You will add these two fractions. The denominator will be LM and the numerator will be M plus L, cross multiplication. These two values are known. Then you convert the unknown value into known values. M and L we know that is equal 7, and the LM we know that is equal 9. Now, tell me the value of m square plus L square. M square plus L square. How can you get this value? From these values, I have L plus M, but you want L square plus M square. How can I get it? We will make a law for this value. M plus L, M square plus L square equal M plus L all square minus 2LM. Then M square plus L square equal M plus L all square. تفضلي.
عايزين حضرتك بس ارقام المجموعات
حاضر.
بس مش التوزيعه الارقام نفسها.
Okay, let's continue. How can we derive this relation? How can we derive this relation? We said that we will take some important relationship to get the value like this value. M square plus L square equal M plus L all square minus 2LM. How can we prove that? This value, if we expand this bracket, we will get M square plus 2ML plus M square. This is the expansion from the perfect square minus 2LM. Minus 2LM will be eliminated with positive 2LM, and we will get M square plus L square, the same value. Then we can use this relation. To get the value of M square plus L square. Then M plus L all square, we know M plus L is equal 7. Then 7 square equal 49 minus 2LM. We know that LM equal 9. Then 2LM equal 2 times 9 equal 18. Then 49 minus 18 equals 31. Another value. Get M cube plus L cube power 3. How can we get it? How can we get this value? Okay. We will make a law to get this value from these two values, m plus l, m cube plus l cube. Now, if I wanted to factor to this value, the sum of two cubic, it will be m plus l times m square minus ml plus l square. Now, m square plus l square equal what? M plus L will be the same value. M square plus L square equal what? We have concluded it. We have concluded that m square plus L square equals this value. Now we will substitute with m square plus L square. M square plus L square equal m plus L all square minus 2ml. We will continue the remaining value, minus ml. Then minus 2ml minus ml will be minus 3ml. Minus 3ml. And this is the final formula to m cube plus l cube. Now, how can we get this value? We will get this value from our known values L and M and Lm. L and M equal 7, then this value equals 7. M plus L all square equal 49 minus 3 times ml which equal 9. Then minus 3 times 9, it will be minus 27. Then 7 times 49 minus 27, it will be 22. Then 7 times 22, 7 times 2, 12, 14, 10 times 2 equal 14, and we will add 1, we will get 54, I'm sorry. Another value. Get m cube times l cube. This is a simple relation. M cube times l cube equal ml all cube. Okay, because they multiplicated by. Okay, ml, we will get it from our value, from our known values. ml equal 9. Then it will be 9 all cube. 9 all cube equal 799. 29. 729. Another relation. Get m minus l. M minus l. How can we get it? M minus l is the difference between the two roots. But we don't have the difference. We have the sum, and also we have the multiplicative. But we don't have the difference between the two roots. How can we solve this? We will make a relationship for it. We will make a law. Okay. To get m minus l, I will firstly get m minus l square. Okay? Some of you should ask, but I want m minus l, just m minus l. I didn't want m minus l all square. He asked me find the value of m minus l. Firstly, you get m minus l all square and get square root to the final value. Okay? Then m minus l all square equal m square. We will expand this perfect square minus 2lm plus l square. Right? Now, m minus l all square equal m square minus 2lm plus l square. We will get m square plus l square together minus 2lm. Now, I want just m minus l. m minus l is the square root of this value because this value equal m minus l all square. Then just m minus l, to eliminate the square, we will take square root. Then m minus l will be square root to this value. Square root to m square plus l square minus 2lm. These values are known, m square and l square. How can we get m square and l square? How can we get them? We make a law for them. We make a law for them. Okay? M square plus L square, we will eliminate them and substitute with their value, which equal M plus L all square minus 2LM. Now, we will add these two values, minus 2LM, minus 2LM. It will be equal minus 4LM. And this is the final formula for M minus L or L minus M. Okay? How can we get the final value? M plus L, we have the value of it equal 7. Then square root to 7 square, which equal 49, minus 4LM. And we know the multiplicated for L times M, it will be equal 9. Then 4 times 9, it will be equal 36. Finally, we will get the final result. 49 minus 36 equal 13. Then the final result of M minus L equal root 13. Okay? Now we make lot of relationship between the roots and the coefficient. Now I will give you the final information about related roots. If you have a quadratic equation, and you informed that one of its two roots is an inversed addition to the other. Inversed addition, that means if the first root is L, the second root will be minus L, inverted addition. That means if you get the sum of two roots, L plus minus M, then the sum will be equal what? The sum will be equal 0 because minus L plus L equals 0. Then if the roots, one of them is the inverted addition, it will be the sum equal 0. The roots are minus 3 and plus 3, minus 4 and plus 4. The sum of them will be equal 0. But the sum of them, we notice that the sum of them equal minus b over a. It's a law. It's a relation between the coefficient. If we make a denominator to this number and make a cross multiplicative, we will get that minus b will be equal 0, and it will lead us, divided by this minus 1, the whole equation, the two sides, b will be equal 0. Then if the equation is an inverted addition, b, the coefficient b, must be equal 0. Then if I give you an equation, 2x squared plus k minus 4x plus 9 equals 0. This equation, I told you that one of its root is the inverted addition to the other root. What is the value of k? We said that if they are inverted addition, b must be equal that. Where is b here? This is b. This is the value of b, the coefficient of x, must be equal 0. This value must be equal 0. K minus 4 must be equal 0. Then k must be equal 4. Okay? Now, another example. If he told you that one of the roots are inverted multiplicative to the other. Inverted multiplicative, not inverted addition. Inverted multiplicative, that means if we suppose the first root is L, then the second root will be 1 over L. That is the mean of inverted multiplicative. Now, if one of roots is L and the other is 1 over L, the multiplicative will be equal what? The multiplicative now, not the sum. The multiplicative will be L times 1 over L. L will be eliminated with L, and the multiplicative must be equal 1. The multiplicative, which has a law, which equal C over A, the coefficient. If we make a denominator here, which equal 1, and make a cross multiplication, we will get that A must be equal C. Important relation. Then, if the two roots are cross multiplicative to each other, must be A equal C. This is the final result, as this in the cross, inverted addition. This case, inverted addition. Okay? This is inverted multiplication. Okay? Now, we will have an example. If you have mx squared plus 4x minus let's make it plus plus m square minus 2 equals 0. This is a quadratic equation. If I told you that the two roots of this equation, the two roots are inversed multiplicative to each other, inversed multiplicative. Now, get the value or the values of m, of the constant m. Now, because the two roots are multiplicative inversed to each other, it must be a equal c. What is a? A is the coefficient of x squared, which equal m, equal c. What is c? C is the constant of this equation. Where is the constant here? The constant don't necessarily be one number, don't necessarily be one term. The constant may be big value. The constant c is any value which didn't multiplicated by x squared or multiplicated by x. Then all this value is c here, because this value didn't multiplicated by x squared neither x. Then all this value is c and this value is a. And we said because they are inversed multiplicative to each other, a must be equal c. Then m squared minus 2, which equals c, must equal m, which represented a. We get a quadratic equation. Solve it for m. Then I will get it to the other side with an opposite sign. Then m squared minus m minus 2 will be equal 0. We can solve this equation now by two ways, factoring or using the quadratic formula, general law. I will use factoring here. Then m squared will be m and n, minus 2 will be minus and positive 2 and 1. The big number take the sign of the middle term. Then m can be equal 2 and the m can be equal minus 1. Now we can make a relation between a and c in the case of inversed multiplication and b equal 0 in the case of the two roots are inversed addition, and we reach to the ending of the session. Now we finished LO number 1 in math, which is speaking about quadratic function, and we will begin in the next session LO number 2 in math. I hope this session was useful for you, and see you in the next session.